So obviously that puts a little bit of pressure on trying to get their presentation right. So again, just picking on what Kerry said, I'm filling in to give the presentation that the Koreans have put forward to us. This is the Korean Rail Authority. There's some background there on who the Korean Rail Authority are. And I won't run through that, but they're obviously quite a substantial organisation. They're like Australia, they've split themselves up into below the rail and above rail. They have an operational side and they have a below rail side as well. So that's pretty standard now throughout Australia. So for example, in Australia, companies like Brookfield, etc. own the below rail, and the above rail are operated by independent operators like Pacific National, QR or Horizon, etc. So it's a very similar sort of setup in terms of infrastructure and outsourcing of the transport systems. There's quite a number of engineers and technical experts in there. Their core business these days is the high-speed rail. That's their solution to their high-density population issues. They still have conventional rail. And when I take you through this presentation, you'll see that what the Koreans have done is had a journey on the technology. So they've started with conventional rail, which is very much like what we have here in Australia, then gone up to what they call semi-high-speed rail, and you'll see the acronym there, MTX, and then you'll see the acronym there, KTX, which refers to the high-speed rail. So they've had this journey since 2000, well, the early 2000s, but in 2004 they had their first high-speed rail. The advantage with the Koreans is that they've got quite a large R&D capability behind them. So whilst they've implemented the high-speed rail in 2004, they've incrementally improved it and integrated research with practical learnings from it to come to a technology now that is proven, reliable, and robust. So this is one of the great advantages of the Korean technology. It is tried and proven, and I note there's some other technologies that are coming to the fore. And one could argue that these new technologies, we should be looking at them, and that is correct. But what the Koreans have tried to do is actually try to future-proof their existing technologies by incrementally building on it and increasing speeds. So the semi-high-speed rail was up to about 200 kilometres per hour. The proposal here is up to 350 kilometres per hour, but through the process and through an iterative process with government. So as you're aware, where there's been unsolicited proposals to come up with a high-speed rail between Sydney and Newcastle. The idea is to work with government and incorporate the future-proofing of the designs by allowing for higher speeds. So for example, you might put the infrastructure in. So when you're designing railways, one of the key aspects is the turning circles. You know, how fast the radius. So the faster you go, the bigger the radius. So as part of the thinking is that they were designed to cater for future higher speeds, but implement the current tried proven technologies, which be at 350k. So the 500 and the 600k is in its formulation now, and I've been informed there is progress on that. But so they are putting in tried and proven technology now and then incrementally increasing that to achieve the higher speeds and the higher technologies. And that's not just through the rail lines, that's also through their IT platforms. So a key part of rail safety is the communication systems, and there's two aspects to the communication systems. One is the actual communications to the control centre, and the centre is the actual fail-safe devices that occur to stop any sort of major accident occurring. So fail-safe, if there is an issue, things automatically shut down or slow down or whatever. So that technology is also been incrementally improved based on tried and proven previous experience with R&D. So that's sort of a snapshot of the approach the Koreans have taken. It's a systematic, progressive, forward-looking approach, managing risk as you go forward. So the existing rail network in in Korea, there's 3 primary high-speed rail lines, cumulative about 600 kilometres, with the design speeds of 350k. That's the current technology they've implemented. And there's a map there on page 3 that shows, them emulating, from Seoul heading south to 2 of the major cities. In addition to that, they assist other countries in implementing technologies as in terms of construction experience, engineering experience, etc. And they've got quite a big presence in Asia, and now spreading to some of the other countries in Africa as well. How did they develop the HSR network? Again, I've sort of touched on that by highlighting the rail lines that they've implemented, the 600 kilometres. There's 3 rail lines. I can't pronounce it, but the Gwangbu HSR phases 1 and 2, the Honam HSR and the Seoul Metropolitan HSR. The idea is to have the cities connected within 90 minutes. So that's virtually from the north part of Korea to the south part of Korea in an hour and a half. I touched on already about the MTX, which is the semi-high-speed rail, and how that was the precursor to the high-speed rail, and how that's been a seamless transition from the MTX to the high-speed rail through their forward planning. There's some details on the project. They're quite substantial projects. So the first high-speed rail in Korea was in 2004, and it was of the order of $19 billion. And the second phase opened in 2010. The more recent one was last year, with another $10 billion, 183 kilometre project. The distance, similar to what we're speaking about in terms from Sydney to Newcastle, about 140 odd kilometres. And then there was the high-speed rail project in Korea, in Seoul, which is largely underground, largely in tunnels. Just running through that, again, there's a bit of a history there about the upgrade from the lower speed rail lines from 90 to 140 up to 100 to 250k. And like I said, eventually the target is to get up to the, 500 kilometre. I think, what did you say, Raphael? 570 is on the table at the moment. So the 3 different projects that we spoke about was the Seoul Metro. Again, a lot of similarities what we're trying to do with Newcastle. Between Sydney and Newcastle, we're proposing underground tunnelling all the way through. So Kerry touched on the environmental impacts. So the idea is very little environmental impacts, very little impact on existing infrastructure, out of the way, so it's plus, and gets over any sort of congestion issues, particularly coming into Sydney. And so with the Seoul Underground Railway, 50 kilometres, 3 stations, and it's in operation and has been for a number of years. So they're the concepts. So, and it's 55 metres deep. At each station there'll be obviously lifts and all that to take you up to the surface, but there'll be basically underground cities as well as an underground hinterland over the top of that. So again, this is in existence, and obviously the Koreans would invite members to come over and actually have a look at this existing operation, because it will have a lot of similarities with what the Korean SpaceCon Consortium is proposing. And you can imagine in Seoul, the congestion is a bit higher than Sydney. The next page, on page 11, just demonstrates how they've integrated the MTX, which is a semi-high-speed rail, with the high-speed rail. So they still have in the same tunnel, they have the semi-high-speed and the high-speed operating in the same tunnel. The thinking behind all this is you can have these grand plans, but they must be economic. So you need to work your infrastructure hard. So instead of duplicating tunnels, they share the tunnels to the point that the capacity is exceeded, then you build a new tunnel. The actual sizing of the tunnels as well is optimised to make sure it's as small as possible within the safety constraints. The bigger the tunnel, the bigger the cost. more earth to be moved, more tunnelling. So I'm an engineer originally, and we're accused of building the grandest plans, but it's got to be economic. So this is what they're coming from. They're coming from a close integration between the business side, the economics, and the actual physical costs to try and get up with a solution that's economic and achievable. Because we've had a history like now 30 years of previous high-speed rails that haven't got up because of economics. So this is about trying to find the right formula to make this project happen. Anyway, some history there. I won't touch on the financing. In Korea, it was a different financing structure, and that's going to be touched on later in the presentation. So I'll leave that alone. The next phases are pretty standard for project management. It just runs through what you do through the planning, design, construction, and operation stages, and there's detailed plans that sit behind that. And we won't touch on it here, but obviously at each stage there's a close integration with the stakeholders, which includes obviously government, includes business, local business, council, and residents, and trying to find solutions that are win-win. For example, with councils, part of this proposal is having the development rights around each of these stations, but is working with council to actually provide areas that council can develop for their facilities, for community facilities, schools, etc. So it's a total integrated approach is what the Koreans are wanting to put forward, so that the impact on the community, on the environment is minimised, and the economic benefit is maximised, not just for the consortium, but also for the community and the flow-on benefits. So I won't go through each of the stages. In terms of tunnels, I think Australia's becoming a bit of a catching up with the rest of the world in terms of tunnelling. There's quite a bit of tunnelling here in Sydney, as you know, with the Lane Cove tunnels, etc. And obviously we're a big mining nation, so you wouldn't be surprised to hear there's thousands of kilometres of underground tunnels out in the outback with all our mining ventures. But the cost of tunnelling has come down, and it's become quite automated. And there's a number of videos that the guys can show you on tunnel boring machines. And John Holland, for example, have done some successful tunnels here, and a number of other companies. So the actual technology in tunnels, the risk side of it is reduced. Again, we talked about optimising the cross section to reduce costs. There's a diagram that John will show a little bit later on the cross section of the tunnel. So it's a multi-use tunnel. It's got rail and vehicles in there, so it's a dual. So it not just addresses the rail problems, it also addresses traffic congestion problems. Through simulation, air tunnel work, they managed to keep the tunnels down to a smaller size. You imagine you've got this high bullet train coming down a tunnel. There's a pressure wave in front of it. So over years of experience, they've managed to address that and pressure alleviate the tunnelling and stop things like ear popping in tunnels. Like, I'm not sure if you know the history, but some of the early trains were quite uncomfortable, the high-speed trains, through movement, your pressure on your ears, etc. So since 2004, they've addressed those problems incrementally. So now the level of comfort can be guaranteed, or virtually guaranteed, in these higher speed trains. So it's not just about having a train that can go quick, it's also about having comfort in the train, which some of the newer technologies may not have the practical experience that the Korean technology has. There's some details about the tunnelling methods. These days, it's relatively standard. It's standard tunnel boring machines with precast concrete units sliding in behind the tunnel. As you tunnel, precast concrete units come in, lock in, and you move forward. Very safe, stable operation. In terms of bridge building, there's a number of methods of bridge building which the company will select depending on the environment and the geography. In this case, because it's tunnelling, there's going to be virtually no bridges. There might be some at the entry and exits, but virtually no bridges.
Can I just clarify, that's if we're talking in Sydney to Newcastle?
Yes, correct. That's a good point. Yeah, so for the Sydney Newcastle, it's totally tunnel, but if this if this technology was adopted, there would be tunnelling, but not as much, say, going from Sydney to Melbourne, and there would be the need for a number of bridges. Again, there'll be conventional design bridges. So I'll flick through all that. The rail welding. One of the beauties about this technology, it's not that different to the way we install rail now. So my history's been in the in not just metropolitan rail, but also in heavy gauge rail in WA on iron ore projects. And this sort of technology where the rails are continuous rails. So I'm not sure if some of the old timers here would remember the old clickety-click rails. That was because the rails were bolted together. These days they're fusion welded together, so they're seamless continuous rail, so there's no noise. And for high-speed rail, that's essential, that it's a continuous process. And again, they use this thermite fusion type welding where they take the two metals, basically bring them together, and because they're hot, they fuse together. Right? You don't see necessarily a weld there on most of them. There is some welding, but very little. Normally it's just bringing them together and they join. So again, that technology is used in Australia, and so there's very little risk with that being adopted in this technology. Turnouts refers to where the rail line turns out, and the ability to be able to install these turnouts is prefabricated. Just drop them in and off they go. If you look at the normal rails around Australia, they're all on sleepers. These ones are going to be on pre-stressed, post-tension stress concrete. So they'll be just dropped in. So it'll be compacted ground, and the sleepers and the rail will just be dropped in as one unit, and it's a precast slab. So there's no potential for movement, and that's illustrated on page 26. And the company has a patent fastening system for fastening these rails. I've already sort of touched on the rail technology has been developed, but one of the key components going on page 29 is the signalling communications. And again, as I mentioned before, that's progressively being improved over time. So it covers signalling, communications, and the power side of it. Now, one of the novel sides on the power side is that SpaceCon is actually very, very active in pursuing green energies, biomass technologies in particular. So taking wood waste, organic waste, chicken litter, etc., and burning it and creating power and feeding that back into the system. So one of their proposals is to actually try and make this as green as possible by utilising other ancillary technologies to generate the power required for the rail. So as part of their offering, they're bringing some of that technology into here as well. So the impact on infrastructure, power infrastructure for this rail line on existing power will be minimal, because they'll be, the aim is to generate their own power, and as part of the smart cities that they're, and I won't steal anyone else's thunder on the smart cities, but that's part of it is generating your own power from waste and capturing the CO2 emissions and reconverting them back into other products. Some of their wireless technology is state of the art, and they're now up to the 4th generation. So again, the iterative process and R&D developing and improving on wireless technology. And again, I won't go into that in a lot of detail. And the last bit of the equation is the maintenance centres, having high quality, fast maintenance centres where the trains can come in, be turned around quickly, back on the track. So the key to this technology is, in the rail industry, we talk about reliability and availability, right? So the reliability is when I put the train on the track, it keeps going. The other component is the availability. So how often is that train available? And that's a function of how often it takes to actually maintain the train. So if it goes down, how quick can you get back on the track? So what this technology brings is the high reliability, high availability based on these years of experience and ironing out the problems. So some of the newer technologies that are coming out don't have that luxury of the reliability and availability. And that's really where I wanted to finish it, unless there was any other questions on the technology. It's sort of broad. We can provide technical, a lot more technical information on each aspect of this technology for closer due diligence. But this sort of just provides a high-level snapshot of what I think the Koreans were trying to express in this presentation.